Hello dear friends, welcome to another video of the Never Do Through the GUI what you can do through the CLI channel. Today you will be watching exploring the Tokio vs async-std performance. Number one, because maybe there will be more videos. If you are following the channel, you may have seen the latest benchmark between actixweb and Tide, and we saw that Tide was outperforming by a significant amount the actixweb framework, and we pinpointed the problem in the runtime itself in the async-std implementation vs the Tokio implementation. So I have been going back and forth with some people and trying to check the issue myself as much as possible, and I want to share what I have I have found so far with you guys. So let me start. First of all, what has happened pretty recently, we had this commit in the Tokio repository about reducing no-op wakeups in multi-threaded scheduler. So this commit added some as you can see, it's 19 days ago. So this commit added some, let's say, improvements to the runtime, to the Tokio runtime, regarding the waking up of threads, and they reduced the wake-ups when waking up a thread was not necessary. So this is a new, let's say, thing that happened, as you saw, 19 days ago, and it added a performance boost to the Tokio runtime. So of course I wanted to test this thing with our benchmarks. So one thing that I did is that I updated the actixweb. Let me show you. Toml, here we are. I updated the actixweb let's say framework and this API that we use to the latest version, and the Tokio was also updated, so we have this patch included, this commit included in our Tokio runtime currently. So I wanted to test this thing and we will test it, but at the same time, while I was looking for information on the subject, I found this pull request here. This pull request which says, do you plan to migrate from Tokio to async standard when it matures? It's from 2019, as you can see, so it is quite old. And it seems that this issue was a known issue back then. We recently discovered it through our benchmarks, but if we look through this issue, we will see that this user provides some information, and he says that async standard handles blocking calls not anticipated by the developer better than Tokio, and he quotes some things from the async-std itself. It says the new runtime detects blocking automatically. We don't need spawn blocking anymore and can simply deprecate it. Plus, the new runtime makes blocking efficient rather than always paying the cost of spawn blocking. We only offload blocking work to a separate thread if the work really blocks. So he's quoting some information from async standard which shows that it works better out of the box, and he goes back and forth with the then maintainer of actixweb. This is the initial maintainer of actixweb who abandoned the project after a little bit of turmoil, and he does not accept anything of this. Liberal Lois also adds some more information, etc. And through this conversation, I at least also learned about web block, which we will check right now. So this is web block, and what this function does is that it offloads to to a thread pool our operations which are CPU bound. So Tokio handles quite good the I/O bound operations, but if we have a CPU bound operation, then this is what we must implement. We must use this web block. So this is, let's say, the information that I have gathered so far, and I wanted to test all this, and we will check it together. So if we come to our project here, this is how we use this web block, and we will use it because our operation, the get users operation, is CPU bound and not I/O bound. So it is better to use this web block. But before we do that, I will use the old way. So this is the old way that we did things, and we will benchmark and see how it goes. Let me get our command, actixweb. We will only use wrk, and we want the system monitor here, yes. So let me prepare it, and let's fire this up, and let's see how it goes. As you can see, if you remember, this is the CPU utilization that we were getting out of actixweb. So we were getting around 50% of the CPU usage, and you can see it here. And this is the question mark that we had, the CPU utilization. We were wondering why we cannot get better performance out of actixweb. So the first thing that we have to do is let's change this and use this recommended way of web block, because we have a CPU bound operation. So the CPU is stressed and we don't have I/O here. And let's kill this and let's rerun. And we will test our output. So let me prepare this. Let's rerun. And let's check the system monitor. So, as you can see, the CPU is utilized better with this change. We get 62% currently. 61%. And we are done. Okay, so as you can see, this change provided an improvement regarding the CPU utilization. Keep in mind, as I said, that we also have the latest Tokio runtime currently, which includes that optimization regarding the wake up calls. So let's make a quick comparison here and let's see our results. Latency 53, so the same. Max 125, max 268, worse here with our change. Requests per second 3.09, requests per second 3000. Max request 3.6, 3.73. So here we have 55,000, no, sorry, 54,000 requests. And here we have 537,000 requests. And the transfer is better here. So as you can see, the CPU got utilized better. the CPU got utilized better, but our overall results are not anything, let's say, quite better. In fact, we show a degradation in the results. So let me rerun this again with this change in scope here. Let's rerun and let's retest just to be sure. So I will retest and let's see. Again, our utilization is 50%. Okay, let's see the results. Here, latency 52, 53, max 268, 103. So we are better, and we were better here, as you can see in the initial run. Request per second 3000, 3000, 3.1K, 3.73, 3.66. 5,000, so we are better again. As you can see, we are about the same number. Request per second, better, the same with this. Transfer, better. So as you can see, even though this web block utilizes better our CPU, the overall results are not better, as you can see. So all this information is quite confusing to me, and I'm sharing this in order for other people to join the conversation and provide their whatever they know on the subject. But I'm just trying to share information here. So to sum up until now we have the latest Tokio, and we are not seeing any huge performance. But no, that would not be correct, because we have to compare it with the previous version. So scrap what I just said, but let's focus on this web block with a straight call here. As you saw, this is the recommended way to do it, because we have a CPU bound operation. But this does not provide any better results in the end, even though the CPU utilization is better. So this is a question mark. And now let's come to comparing the latest Tokio with async-std again. So by the way, before we go there, let me also comment out this setup, the workers, in order to get the configuration that is provided by default by the server, the actixweb server. So we will not get the physical cores, which are 8, but we will get the logical cores, which are 16 currently. And we will also use this recommended way of web block. So let's try this and see if we get anything substantially better. So we are ready. Let's run. The CPU is again the same, and the graph is very similar to the previous configuration. So still CPU 61, 62, 60, and this is the graph. Okay, let's check the results. Latency 54, 52, so we are a little worse. Max latency 155, 103, a little worse with the latest configuration. Request per second 2.98, so it is worse. max 3.38, 3.66, so it is worse. 534,000, 17,000.7 requests per second. So we are worse across the board. So this seems that it is a configuration that we want to preserve. Okay, we are done with trying out actixweb and Tokio itself and the web block recommended way. So now it's time to compare this, the latest Tokio, and the recommended way of using web block with async-std again and tide. So let me come here. We will use this result. Let me kill this. I have also an updated async-std tide application, so let's run it. Cargo run release reset. Let's come here. Let me get the command for tide. Copy. So the same command, as you can see, 30 seconds, and let's start benching. The CPU is better utilized, as you can see, far better utilized. The memory, I don't know if you saw that, is also a lot less. With actixweb we reached the 200 megabytes. So better CPU utilization, better memory usage, which means less memory. And let's compare. These are our results that we want. These are our best results. So latency 52 with 42, max latency 103 270, request per second 3.10 4.08, max requests 13.55k, max requests 3.66k, 71,000 requests, 555,000 requests, requests per second 24,000, 18,000. 1.84 gigabytes, 2.3 gigabytes. So as you can see, the benchmark with the latest Tokio and the improvements on Tokio runtime, plus the recommended way of running this CPU-bound operation, still lacks very much compared to async-std. So still async-std amazes me, and I will continue looking into this issue. A viewer of mine contacted me and told me that he saw better performance on Windows for actixweb and Tokio, and this is something that it is pending. I am waiting on information on the subject by him, but it seems very strange to me that actixweb and Tokio would perform better on the Windows platform, because I suppose it is developed primarily on Unix, let's say, systems, Linux or Mac, etc. I'm not sure though. But overall, the point is that all this information still is confusing to me, because I haven't reached the end, let's say, result of this search of mine for the performance of Tokio compared to async-std. And my questions is, since async-std performs so well with this CPU-bound operation, why can't Tokio implement something similar? For example, we saw in the comments here, in this issue, sorry, that async-std detects blocking automatically. So this is quite huge because it prevents, let's say, lost performance due to our implementation, to the developer's implementation. For example, as I said, I didn't know about this web block, that I should use this for CPU-bound operations, etc., etc. So if the runtime automatically handles this stuff, this is better for everybody, I think. And we gain performance that in a different case we will leave on the table, out of the box. So these are all questions, and this is the information that I have so far. Still looking into the issue, and I hope that maybe somebody will come up, will step up and provide more information, maybe from Tokyo itself. I didn't have the chance to talk to anybody related to the Tokyo runtime. I will try to do that, but for this video, this is the information that I wanted to share. Thank you for watching, if you indeed watched the video, and have a great day.